Hi, this is David Kavanaugh. I'm putting together some parts for a robot I've been working on for the robotmissions.org project. And there's some pieces that I've already welded some pieces. I did a previous video showing how I welded the seams on this scoop, which is made in 3 parts. The pieces that support the wheels underneath the robot are a little complicated tubular arrangement, and I thought I would try welding these together. And so here you see parts that I've already welded. You can see that looks like there's been material that I've added in here by taking a piece of used filament, which is a little hard to see on the camera, I guess, but yeah, so I cut a piece of filament off the spool, and I'm able to melt it into the seam and join the pieces together. And so that's what I did over on this other piece, and I'm going to show you attaching this piece in the same way. Now, to do this, I have a soldering iron with a fairly wide tip. Not the stuff I'd use for soldering fine electronics, but something wider, a little heavier duty. And with the broad tip, it gives me the ability to shape things better. Now I have the soldering iron set. This is a nice iron that I can set the exact temperature on digitally, and it's set around 400 degrees, which is Fahrenheit. So that's around 200 degrees Celsius, which is the melting point of the plastic. And this is all PLA. So it has a fairly low melting point. So the first thing we want to do is join the pieces together so that they'll stay. I took a rubber band and I put a knot in it, so it's a size that works for this and holds the pieces pretty tight. And so there we go. I need to make sure this stays in the closest possible way. It won't move much once there's enough tension. First of all, I need to tack one piece of this down to start holding it together before I can do the entire seam. And so I'll start by putting some filament in the crack, in the joint, and then holding the iron on it until it melts, making sure that the pieces stay in the position I need them to be in. And once I have a little bit of this on here, I can sort of push it towards the other pieces, and then I pull the filament away, leaving a little bit of a glob there, and I can work that with the soldering iron a little bit to heat up the pieces I'm connecting to, and then I want to hold it together. And what's happening here is that because the plastic was warm, it has a little bit of flex, at least until it sets up. You know, this stuff is pretty hard when it's cooled down. And so that's getting cool now. So once that sets up, it helps lock it into place. And what I'm trying to do is make sure this stays in the right position. I want this to end up being perfectly aligned when I'm done. And so now that that's had a little chance to cool, I will turn this over and do similar thing on the other side. I'll get some heat on this, and so that filament will start to soften up, and once it does, I can pull away my bigger piece, and I can kind of smooth that. I can warm up the pieces that it's connected to, and then I'm going to hold that together. Because my goal here is to take away the rubber band and be able to work the entire joint continuously. Alright, so let's see where we are. Take the rubber band off, and so that's kind of holding in place. I believe that's where I want it to be. And so let me just find a starting position here. Alright, so my goal is to take this piece and start it in the joint, and then work it down through the rest of it to form a continuous piece or continuous seam. I'm going to start it this direction because I've got quite a distance I can go around here, and that way I don't have to stop and change position again. So I'm going to take the iron and I butt the piece up against the part that I already melted, and my goal here is to soften it and flatten it into that crevice. And now that I've got that started, I don't have to hold the filament anymore, but I can hold the piece in a position that makes it easy to reach with a soldering iron, and I can simply work that into that crack in the direction of the crack. So I keep backing off the soldering iron over the filament, and what it's doing is it's getting that to adhere into the crack. And I know, I apologize, I should have better overhead lighting, make this easier to see on camera. But what I'm doing here is I'm not making this perfect right now. I am trying to get this in the position it needs to be in, so it's not going to move at all. And now I'm just getting the filament over this little gap here, and then there's the point where I'd started this before, and if this is soft enough, it just pulls right away. There we go. And so now I want to go back over that entire joint and make sure that the joint is smooth and it's properly connecting to both sides. You can see how it's, if you see that it's not joined to one side or another, it's going to be a weak joint. So if you see a visible crack there, and for the soldering iron at this temperature, it does not have to. It's not going to burn through the plastic too easily because it's not hot enough. If you left it on there for quite a while, yes, you would sink a hole through the plastic. But by keeping the temperature a little bit low, it takes a little patience to get this done because you need to allow the heat to do its thing. But you're less likely to make a mistake. All right, and so that entire joint around this side is now complete, and I just have to finish this off. So that's it. I hope this was helpful, and see you later.